Okay, don't run. I know the directions said proofs, but we're actually not going to do full official proofs. We are going to do pretty similar to what we did previously, where we're just going to solve for x. So, key word we are going to use today is what is called the converse. And no, I don't mean the sneakers. No running with your Converse sneakers on. But what converse means is, let's just start by our basic statement that we learned yesterday or the day before, whichever day you did your 3.2 notes. We learned the statement of if then. Okay. If two lines are parallel, then such and such is true. If two lines are parallel, alternate interior angles are congruent. If two lines are parallel, same consecutive interior angles are supplementary. So we learned all these if-thens. The converse is we switch the order, okay? So instead of saying if they're parallel, then we're going to say if such and such happens, then the lines are parallel. So switch the order. Pearl really wants out. Sorry about that. If alternate interior angles are congruent, then the lines are parallel. If same or consecutive interior angles are supplementary, then the lines are parallel. So it's really just using what we learned previously. We're just going to now switch the order in the questioning. Hop into our notes again for this lesson. So right up above, click that pairs of lines and angles for 3.3. Make a copy of the template. Make sure change your name if you need to on there. And then if you do want to print this out, you can click that share button. Click download, and then if you're going to print it, I would say a PDF best for printing, and then hit download, find it, and then print it. We can zoom in here. We're going to use our Canva tools to do this one. So I'm going to scroll down and do it as the answer key. Your warm-up today in live class, we're going to do this fun puzzle. So be sure to come on time to live class, work on that puzzle. You can finish it on your own if you would like to before class. I want to go through these theorems and postulates. They are small. I don't want to try to fit them in here, but they're really identical to what we learned in 3.2. Again, we're just talking about the converse, so I'm just switching the order. So I just want to go through these, and then we'll do some examples. So the first one, it says 3.5 corresponding angles converse. If two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So for example, if 2 and 6 are congruent, then line J is parallel to K. Notice in these images, you're not starting by showing the lines are parallel. We don't have those markings on those lines. We're saying, okay, if they're congruent, then we can prove they're parallel. So we don't know they're parallel yet. We're going backwards. 3.6, alternate interior angles converse. If two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. So for example, in this case, if angle 4 and 5 are congruent, alternate interior angles, then line J is parallel to K. 3.7, alternate exterior angles converse. If two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. So if angle 1 is congruent to angle 8, then the lines are J and K are parallel. And again, those lines here, those little tiny markings there, J and then two lines up and down, that means parallel. And consecutive interior angles converse. If two lines are cut by a transversal so that the consecutive interior angles are, don't forget, not parallel, they are supplementary. That is a massive highlighter I just used there. Again, angle 3 is acute, angle 5 is obtuse. Together, they add up to create a straight line, and they are supplementary. So if angle 3 and angle 5 in this case are supplementary, add to equal 180, then the lines are going to be parallel. So feel free to print this out, keep it. You don't have to memorize these, but they will come up, so it's important to know them. And you're going to do a little bit of doodle notes in live class, fun stuff. So again, if you want to print and find some colors, you can use those for some doodle notes. And the examples we're going to do today, we just have 2, and then we might do some constructing of parallel lines using math SPAD. So this is find the value that makes x or of x that makes line M parallel to line M. Again, notice we don't know that M is parallel to N yet. We need to prove that. So we first want to decide what kind of angles are these that are given here. This angle right here that's measured as 140 and this angle here that's measured as 2x minus 4. What type of angles are those? Notice they're, this one's in the interior, this one's exterior. Which type was it so that they were that? And they're on corresponding parts. Those are called our corresponding angles. And we just learned that if corresponding angles up here, if corresponding angles are congruent, then the lines are parallel. So these angles must be congruent. Congruent means equal. So 140 must equal 2x minus 4. I'm going to add 4 to both sides. Okay, we want to solve that for x. So we're going to divide both sides by the 2. So 144 divided by 2. 72 is going to be our x. And it was 72 equals x. We would do that reflexive property to switch that order, and x equals 72. If you wanted to be picky about that, math teachers are picky. So x equals 72 in order, and that would be the only number that would work to make that those lines would be parallel because those two angles must be congruent. One more example. Is there enough information in the diagram to conclude that M is parallel to N? Well, we could do a few things here. We don't know a theorem about same side exterior or corresponding exterior angles, but we could actually prove that that one is true. So we do know a lot of things. We know vertical angles are, there's many ways to solve this. I'm just going to use the information that we do know. We know that vertical angles are congruent, so that means that this angle here is also 75 degrees. We know the vertical angles, so that means this angle here is 105 degrees. And then looking at those two angles there, the 75 and the 105, what type of angles are those? They're both in the interior and they're on the same side. So they are consecutive interior angles. And we learned up here again that if consecutive interior angles are supplementary, then the lines are parallel. So let's check that. Are our consecutive interior angles supplementary? Supplementary means their sum is 180. So we could do 75 plus the 105. Is that going to equal 180? It sure does. And so if supplementary or consecutive interior angles are supplementary, then the lines are parallel. So the answer in this case is yes. Math SPAD. This is optional, not required. Sometimes it's fun to see these done using these construction tools, so you can kind of see why that the lines are parallel and also why corresponding angles are congruent. So we're going to start with a point. So I'm going to draw a point and a line. So line below the point. Okay, so in order to do this, we're going to first draw a point and a line. Start by drawing point P. We did that. And line M. Choose a point Q anywhere on line M and draw line PQ. So we're going to draw a line through our point here and through our line here. So that's our first step. Okay, draw an arc with center Q that crosses line QP. Okay, so we're going to get our compass out. Okay, we're going to put our center right here at that intersection. I am going to make it a little smaller. I'm actually going to change the color too. I'm going to lock it. And then I'm going to draw my arc. So again, grab the top and rotate it. Using the same compass setting, draw an arc with center at P. So we're going to take this and put it right at that point right there where it crosses. And mine is kind of down here. So then we're going to draw another arc. Okay. All right, what's next? We're going to copy the angle. So draw an arc with a radius of AB. So we're going to open our compass so that it mimics this. So we're going to unlock it, open it up so that we have this mimicked opening here. And we're going to lock it. I'm going to change the color now again. Okay, looks like we're going to put our point, this intersection up here, which we don't have. So give me a second here. I'm going to need to redraw this one. I'm going to draw this longer. I need to go a little bit longer there. Same line. Okay, that's better now. So, trial and error on some of these. Okay, so now we're going to grab it and we're going to open it up so that we are here. We're going to rotate it. Let's rotate my compass first. Okay, we're going to open it up so it crosses here. And we want to cross this line. Where does it cross at? So we're going to make an arc. And again, I'm going to change my color of this one to green. Okay, that's important where that crosses. And then we create a line segment through this intersection and this one. Lots of steps, right? Practice, they're fun. So we're going to make a line that goes through this point and then where they cross there. Those two lines should be perfectly parallel to each other. And again, the reason is because of this opening right here that we created is congruent. It is the same measure as this opening here that we created, and those are called corresponding angles. And again, if corresponding angles are congruent, then the lines are parallel.